Hello, this is Susie Newhan, and this is the second of two videos on solving basic algebraic equations. So just a quick note about rearranging equations. We've been looking at if we want to get rid of this minus 2, we add 2 to both sides. Yeah, we've been doing this. And so that makes us think both sides of the equation, add 2, that will go away, it will appear here. So that would be 8x equals 2x. So we're adding 2 to both sides, so it becomes minus 7, less negative. But that's really only how you learn it when you're beginning. It gets much easier. After a while, you just get used to the idea that I just want to move it to the other side of the equation. And every time I move anything to the other side of the equation, I change the sign. So that's the sort of little cost of moving something over the equal sign. I've got to change the sign. That way, everything's automatically kept in balance. So for instance, if I decide I want to move the 2, then I move it to the other side. But I must change the sign. That's it, that's nice and easy. So 8x equals 2x minus 7. Now the 2x, I might decide I want to move that to the other side. And what do? I move it, but I have to change the sign. It's positive here, so it's positive now, so it becomes negative. Equals minus 7. So 8 lots of x minus 2 lots of x, 6 lots of x equals minus 7. So x equals minus 7 over 6. Yep, so we moved that and made it positive. We moved this and made it negative. So in the previous video, we only looked at equations with a single unknown term, a single x term. So now we're going to crank it up a little bit and we're going to look at equations with more than one unknown term. So let's have a look. So here we have some x's on this side and x's on the other side, but this is fine, we can handle this. As I said before, to solve equations, we really want to get the x on one side and everything else on the other. So we're always trying to sort of extricate x, or whatever the unknown is. So let's think, a good way to do that, wouldn't it, would be to get the x's on one side and everything else on the other. So let's just, as we were before, let's get rid of this minus 2. How do we get rid of the minus 2? We're going to add 2. I might do this in a different colour. We're going to add 2. And what that's going to give us? That's going to give us 5x equals 2x. And we're going to add 2 to this side, and that's going to give us minus 9. All right, so that's looking good, but now we'd like to get the x's together. So how am I going to get 2x off that side? Well, you remember from before that we have to do this thing where it balances, but it simplifies at the same time. So if we want to get rid of that, we have to subtract it. But we're not subtracting 2, we're subtracting 2x. I just realised I've got to say what we're doing with the 2 there. We're adding 2. All right, but this time we're subtracting 2x because that will get rid of the 2x term. So we've got to subtract 2x from both sides. So we subtract 2x from 5x. 5 lots of x minus 2 lots of x gives us 3 lots of x. So the 2x has now been absorbed into the 5 and has now gone away on this side, so it leaves the minus 9. So what do we do next? Well, we know we've got 3 lots of x, but we only want 1 lot of x. So what we're going to do is divide both sides by 3. So we're going to have 3x divided by 3 equals minus 9 divided by 3. And we looked at before, if we're multiplying and dividing x by 3, then that's the same thing as not doing anything to x. So those cancel out and leave a nice clean x. And 3 divided into minus 9 is minus 3. So let's just do the same thing here. Right, So here we took the 2x to the 5x. Why did we do that? That's because there was more x's on the left side. But here, look, there's more x's on the right side. So that's where we want to congregate our x's. Because if we take 15x over to the other side, we're going to end up with a negative number of x's. And we just don't want to do that. Let's keep it nice and simple. So we note that there are more x's on this side. So this is going to be our x side, which means we want to get rid of the 19. How do we get rid of the 19? We're going to subtract a 19. So to subtract 19 from both sides, we're going to get 7x. Ooh, now we've got plus 3 minus 19. So that's going to give us minus 16 equals 15x. So the 19 has gone away now, so it's already looking a bit more comfortable, isn't it? So now we want to get the 7x over to that side. And how do we do that? We subtract 7x from both sides. Now, some of you might be noticing that there's a pattern here. Every time we take something to the other side, it changes sign. And that's where the shortcut comes in. When you get better at algebra, you'll just change something to the other side and you'll change the sign. So we've got 7x on this side. If we want to take the 7x to the other side, we can just move it across and change the sign. For instance, I'll do that with an extra step here. So you can see that I can move the 7x over the equal sign, but the cost of doing that is always changing the sign. If it was negative there, it would have to be plus there, and it keeps the equation balanced. So let's tidy this up a bit. I've got minus 16, I've got 15 lots of x minus 7 lots of x, so that's 8 lots of x. Good, it's getting simpler. So 8 times x equals minus 16. How are we going to strip out just the x, get that on its own? We're going to divide by 8. Remember, if we've got 8 lots of x and we want 1 lot of x, we have to divide both sides by 8. So that's going to give us a single x, great, and minus 16 divided by 8 is minus 2. Just notice that my pen is dripping a little bit. All right, and of course us mathematicians, we don't like to have x on the right side, so usually switch it around, it doesn't matter. All right, one more. Right, so now we have to be a bit strategic because we see we've got 5x here, which on the surface looks a bigger number than 3x. So you might think we want to bring 3x to the 5x, but what do we notice about the 5x? We notice that 5x is negative. So really there's far more x's here because these are positive ones. As we've said, if we take something to the other side, it will become positive, and that's much more comfortable. So we're going to make this our x side. That means we want to get the 10 to the other side. So what are we going to do? We're going to add 10, which is the same thing as moving the 10 and making it positive. So adding 10 to both sides, we've got 18 minus 5x equals 3x. And now we want to bring the minus 5x over to the other side. And how do we move the minus 5x? It's the same thing as adding 5x. That will get that away from there. So that now gives us 18 equals 3x plus 5x. Extra step there that we didn't really need, but helps keep it clear. Okay, so this is looking much better. So now we've got 18 equals 8x. Yep, 3 lots of x plus 5 lots of x, 8 lots of x. And the final step now is to divide both sides by x, 8. If we divide 8x by 8, we get a single 8. So here's us dividing both sides by 8. We could leave it as a fraction. If we're going to leave it as a fraction, we ought to at least simplify it, which means cancelling down as much as we can. That's the same as 9 over 4. Or we could give it as a decimal. We tend in algebra to use fractions, not decimals, until the very end, because fractions just lend themselves to algebra so much better. And they tend to be more accurate because we're not losing places of decimal. All right, so the next one involves brackets. Now, brackets just tells you that the thing on the outside must be multiplied by everything inside the bracket. So we have an extra step where we multiply or expand out the brackets. So let's do that extra step. We've got, so 4 times x plus 4 times 2. And now we've just got an equation like we were doing before. So this is our x side. Let's move the 8 to the other side. How do we move the 8? Well, it's the same thing as subtracting an 8. So we've got 4x equals minus 3 minus 8, which is minus 11. And now we're going to divide both sides by 4 so that we get a single x. All right, now we've got 2 sets of brackets, but that's all right. We'll start by expanding them. So 3 times 2 is 6 minus 3 lots of x plus 5 times 4 is 20 plus 5 lots of x. Now we collect our like terms. So we can put the we can put the x's together and we can put the constants together, the numbers together. So putting the numbers together, we get 26. So we've got 5 lots of x minus 3 lots of x is plus 2 lots of x equals minus 9. My x came adrift. So we'd awfully like to get that 26 out of there. So we're going to subtract 26 from both sides. So we get just x's all on their own. Minus 9 minus 26 is going to be minus 35. Now, the temperature is already minus 9 in Moscow. It drops by another 26. So it's an eye-watering minus 35. Possibly not very eye-watering at that temperature. And then we want a single x, so we divide by 2, so we get x equals minus 35 over 2. Right, so that's enough of those. So just a couple of little ones where we have some square terms, or cubic terms, it doesn't matter, I've picked square ones. So here, it's very similar to before. We want to get the x's all on their own, so we want to get the 2 to the other side. So we're going to do what we keep doing, which is adding that number to the other side. So then we get x squared equals 9. Now, some of you will recognise straight away that we can see that x is 3. But what does that mean? It might be a number that you can't do in your head. So if x squared is 9, it means that x must equal the square root of 9. And that we can get from our calculator. And the last one, we've got 2x squared minus 1 equals 32. Let's move the 1 over to the other side, which means adding 1 to both sides. So that leaves us with 2x squared equals 33. I don't think I meant to do that. I think I meant to make that 31. So that it's a nice even number. So we move the 1 to the other side and we get 32. Then, right, now we've got 2 times x squared. So the way we're going to simplify this is divide both sides by 2, because we want to get just x squared on its own. Well, so dividing 2x squared by 2 gives us a single x squared. Now we know that x equals the square root of 16, which equals 4. So here's some questions. So as always, freeze frame, have a go, and then I'll put the answers up afterwards.